All right, so today we're diving deep into the world of microbiology. Specifically, we're looking at a fictional case of necrotizing fasciitis.
Nasty stuff.
Yeah, it is definitely not something you want to mess with. Our main source for this deep dive is going to be the OpenStax Microbiology textbook.
Great textbook.
Oh yeah, it's great. And as always, you can find a link to that in the video description below. Now imagine this. It's a beautiful spring day. You're out in the garden, maybe doing some pruning, and you get a little scratch.
Happens all the time.
Yeah, you figure, okay, no big deal, just clean it up later. Well, that's exactly what our guy Mark did.
Mark.
Yeah, Mark, he's a 60-year-old software engineer. He's out there tending to his blackberry bushes and picks up a little scratch on his leg. Doesn't think much of it.
Those blackberry thorns can be pretty nasty, though. A tiny injury can be an entry point for bacteria if it's not cleaned properly.
Oh, for sure. And so Mark kind of shrugs it off initially. But then over the next few days, the area around the scratch starts to get really red and swollen and painful, classic signs of inflammation.
Right. Inflammation is the body's natural response to trying to fight off, anything that shouldn't be there.
Yeah, the body's like, hey, something's wrong here.
Exactly. But in Mark's case, it was a little more than the body could handle on its own.
Because those symptoms, they didn't just go away. They actually escalated quite quickly.
Yeah.
So we're talking high fever, pain shooting deep into his muscles.
And feeling so weak he can barely stand up.
Yeah, it's like this went from 0 to 60 in no time. This isn't just a normal infection anymore. Right?
No, this is a big red flag. This is when you know something more serious is going on. And you have to remember, necrotizing fasciitis, it's known for being very aggressive and spreading rapidly.
Yeah.
It's not something to wait on.
You got to act fast. So 2 days in, Mark's feeling absolutely terrible. Finally, he calls his neighbor to take him to the ER.
Good thing he did.
Yeah, and just imagine you're in that emergency room with him. The doctor takes one look at his leg, and well, let's just say, it's not a pretty sight.
Yeah, the skin's discolored. There are blisters forming.
Oh, no.
Filled with pus that has a really, really bad smell. And even worse, some of the skin is actually starting to turn gray.
That's just awful. So this is definitely beyond your average infection, right?
Definitely. This is classic necrotizing fasciitis. Sometimes it's called the flesh-eating disease.
Oh, wow.
And that's pretty accurate. It spreads through those soft tissues, and it basically destroys everything in its path.
It's like a fire burning under the skin.
That's a good way to put it.
So at this point, the doctor, they know they have to act fast.
Absolutely. They have to move quickly. They start treatment for necrotizing fasciitis right away.
And they take a culture from one of those blisters, I assume?
Yeah, they need to try to figure out which bacteria is causing the infection so they can get them on the right antibiotics.
Okay, so they do that, they take some blood work too, and then, whisk him off to the ICU?
Straight to the ICU. Hook him up to 5e antibiotics. And because they don't know exactly what they're dealing with yet, they start with broad-spectrum antibiotics.
Right, kind of like a catch-all.
Exactly. They're hoping to hit the target while they wait for more information.
Yeah, hoping something sticks.
Mm-hmm.
But I'm guessing that doesn't quite go as planned.
No, unfortunately not. Despite the antibiotics, Mark's condition continues to worsen.
Oh, no.
His blood pressure drops dangerously low, his breathing becomes shallow, and it looks like the infection is still spreading.
That's terrifying. So what do? I mean, the very thing they're giving him to help him isn't working.
It's a nightmare scenario, and it suggests that the bacteria causing the infection might be resistant to the antibiotics they're using. It's getting really interesting now and a little scary. Mark was about to undergo surgery.
Yeah, a pretty intense surgery to try and stop this infection that just wouldn't quit.
It's like trying to contain a wildfire before it just burns everything down.
Yeah, that's a good analogy. And, you have to think about what Mark's going through. I mean, he's already so weak from the infection.
And now he's facing this major surgery.
Right. It's got to be incredibly scary for him. So tell me about the surgery itself. What do they actually do?
Well, it's very complex. They have to remove all the infected tissue.
All of it.
As much as they can, yeah. And with necrotizing fasciitis, that can be a lot of tissue.
So they're basically trying to cut out the infection, like carefully removing all the damaged areas.
Yeah, exactly. They're trying to salvage what they can. But the surgery, it's just the beginning, The recovery process after this is long and it's tough.
What does that involve?
Multiple surgeries, most likely, and skin grafts to replace the tissue that was removed.
Wow.
And then months and months of physical therapy.
That's a long road.
Yeah.
And is there like a guarantee that he'll make a full recovery?
Unfortunately not. I mean, Necrotizing fasciitis, it can cause such severe damage.
Right.
Even with the best medical care, there's a chance that he could have some permanent disability.
So even if he survives this, he might not ever fully regain the use of his leg.
It's definitely a possibility, yeah.
That's just heartbreaking.
It is. It's a reminder of just how serious this infection is. But, it also speaks to the incredible skill of the medical team, the surgeons, the nurses, everyone who's working to save his life.
They're really the unsung heroes in all of this.
Absolutely.
Okay, so while Mark's fighting for his life in surgery, the lab's working hard to identify what exactly is causing this infection. It's like a medical detective story. They're trying to track down the culprit.
Right, and they finally get the results.
Okay.
It turns out to be Staphylococcus aureus.
Staph. Isn't that, pretty common? I thought everyone has staph on their skin.
You're right, staph is everywhere. But this particular strain is special. It's methicillin-resistant Staphylococcus aureus.
MRSA.
Yep.
Okay, so that's why those broad-spectrum antibiotics weren't working. This MRSA, it's resistant to a lot of the usual antibiotics, including methicillin.
Exactly. It's a much tougher opponent.
So how does a strain of staph become resistant like that? I mean, where does that come from?
Well, bacteria, they have this amazing ability to share genetic information with each other.
Sure. You mean like swap genes back and forth?
Sort of. It's called horizontal gene transfer.
Okay. Break that down for me.
So imagine you have a group of students studying for an exam. Some students have really good notes, right? And they share their notes with their classmates to help them out.
Yeah, I get it. So one bacterium that has antibiotic resistance genes can actually pass those genes along to another bacterium, even if they're not related.
Exactly. It's like they're trading secrets to help each other survive.
And this is probably what happened in Mark's case, right?
It's very likely, yes. The CDC looked at the virulence genes in Mark's staph strain, the genes that make it so aggressive.
Right.
And it looks like those genes were probably acquired through horizontal gene transfer. And here's the crazy part. This gene transfer might have actually been triggered by the antibiotic treatment itself.
Wait, so the very thing they were giving him to kill the bacteria could have made it more dangerous?
It's kind of ironic, yeah. Antibiotics, they create what's called selective pressure.
What does that mean?
So you give antibiotics, and they wipe out all the susceptible bacteria, the ones that aren't resistant.
Right, the weak ones.
Exactly.
Yeah.
And so the bacteria that are left, the ones that are resistant, they have more space and resources to grow and multiply.
And they can share those resistance genes with other bacteria through horizontal gene transfer.
Right. So in a way, using antibiotics can actually contribute to the spread of antibiotic resistance.
That's a scary thought.
Yeah.
So it's not just a problem for Mark, it's a much bigger problem for the future of medicine. If we keep creating these superbugs that are resistant to all our antibiotics, what happens then?
It's a huge concern, no doubt. The rise of antibiotic resistance is a major global health issue.
Okay, so we've got this dangerous infection, a resistant bacteria, this crazy gene-swapping ability.
It's mind-blowing, isn't it?
It is. It really is.
Yeah.
So what happens next? What's Mark's fate? We'll find out in the final part of our deep dive into necrotizing fasciitis. Welcome back to our deep dive into the world of necrotizing fasciitis. We've been following Mark's story, from that simple scratch to this incredibly serious, life-threatening infection.
And we've learned about MRSA and how it's resistant to a lot of our antibiotics.
Right, and not only that, but how these bacteria can actually share those resistant genes with each other. It's kind of wild.
It's like they have their own little underground network, passing along those survival tips.
Exactly. So last we left off, Mark was in surgery and facing a pretty uncertain future. I mean, what are his chances of really recovering from something like this?
Well, it depends. Necrotizing fasciitis can cause a lot of damage to the tissue,
Right.
Even if he survives, there's a chance he could have some lasting effects.
Like what?
Well, he might have some permanent disability. He might not ever fully regain the use of his leg.
Oh, wow. That's really tough.
It is, yeah. It really shows you how serious this infection can be. But you also have to remember, the medical team that's treating him, they're doing everything they can. They're incredibly skilled.
Right. They're the real heroes in all of this.
Absolutely.
Okay, so thinking about everything we've learned about this case, about necrotizing fasciitis, about MRSA, about horizontal gene transfer, what are the big takeaways? What should people really understand about all this?
Well, I think, first of all, it's a reminder that even seemingly minor injuries, like a scratch, can become really serious really fast.
Don't mess around with infections.
No, definitely not. If you have a wound that looks infected, or if you're just not feeling well, fever, chills, any of that.
See a doctor.
Yeah, get medical attention right away. It could make all the difference.
Okay, so that's the first thing. What else?
Well, the second thing is that antibiotic resistance, it's a growing problem.
We talked about that.
Yeah, and it's something that we all need to be aware of.
Because it's not just about Mark. It's a global issue.
Exactly. And finally, I think this case really shows how important it is to understand the world of microbes.
Those tiny little organisms.
Right. They might be small, but they can have a huge impact on our lives.
And they're constantly adapting and evolving.
Which is why we need to keep learning, keep researching, keep trying to stay one step ahead.
Absolutely. Well, thanks for joining us for this deep dive into the world of necrotizing fasciitis. We hope you learned something new. And we hope it maybe gave you a new appreciation for the incredible, sometimes dangerous world of microbes.
It's a fascinating world for sure.
And if you want to dive even deeper into this topic, don't forget to check out the OpenStax Microbiology textbook. We've got a link to that in the video description below.
Thanks for listening, and we'll see you next time.